exercises from NumPy. And today we do something called Pandas, right? Now I have made a PPT as well. Just quickly go back here. This is Pandas. Well, this is not Pandas. It is a module in Python which you can use to manipulate files. Is there anyone who's used external modules in Python before other than NumPy or Pandas? Raise your hand if you have. Okay. Yeah. I do see one person here. So yes, I'm going to assume a few people have used external modules in Python. But yes, so as I had mentioned before, yesterday that is, Python has some built-in modules and some external modules which you can import and use according to your purpose, what you need it for. So if you want to do some more mathematical, if you want to imply some more mathematical concepts than the ones that are already invoked in Python, you can use math. So you can import math, but it is a built-in function. But if you want to manipulate these numbers further, you have to use NumPy. Similarly, there are files on your computer and you want to see these files, you want to open them, you want to place them somewhere, you want to read the contents of them and create a Python program using these databases. You use Pandas for that. So yeah, I thought this was cute. So I put it here. Okay. What is Pandas? Brr. Thank you. You can consider Pandas to be similar to Microsoft Excel, just buffed up 100 times. All right. So it is basically a database management module, similar to it, that is. And we'll be going through the uses of Pandas on the field of data analysis. This comes extremely handy when handling large amounts of data, right? Series of the topics we'll be going through are series, data frames, missing data, group by, merging, joining, concatenating, and some basic operations that you can perform. Okay. Now, what is series? In general, what can you define a series as? Anyone? Just a general explanation of what a series is. Anyone? It's English.
Numbers.
Sorry?
The sequence of numbers.
A sequence of numbers or a sequence of anything, actually. It doesn't have to be numbers specifically, but yes, you are right. A sequence doesn't have to be in order, but it has to be a sequence of something. Okay. Main data type we need to look at for pandas is the series data type. It is extremely similar to NumPy array, except the fact that a series can have an access label, which means it can be indexed by a label instead of a number location. So you have your arrays, you have your lists. In your arrays and lists, your positioning is marked by 0, 1, 2, 3, 4, 5, and so on. In series in pandas, what you can do is instead of the 0, 1, 2, 3, 4, 5, you can mark it with anything you want to. You can mark it with A, B, C, D, E, W, X, Y, Z, A, B, C, D, E, USA, Germany, China, Japan, Indonesia, Palestine, Russia, whatever. Whatever you want to do, you can do. Okay. When it comes to label naming, that is. A series can hold any Python object and doesn't necessarily have to be numeric data. What does this mean? It means instead of numbers in your lists and arrays or strings in your lists, you can put any Python object. You can put functions as well. Some predefined functions, any examples of some predefined functions or in Python, like add, any others?
Sort.
Sure, sort works. Split, anything else? Len for the length of objects. Pow for the power.
Append.
Append, correct. You can add all of these into a series. Okay, so a series can hold any Python object. Please remember this. I'm going to perfect. Side note, you can install pandas by typing pip install pandas if you're using pip, or conda install pandas if you're using anaconda. I'll go through the code in a second. Series continued. All subsequent slides contain notes on pandas and references must be taken from the uploaded code snippet. Okay, I will upload all of these code snippets along with the PPTs. Okay, so you guys won't be confused. Series and pandas can be used to convert a list, a NumPy array, or a dictionary to a series using a very simple line. pd.series, note this S being capital over here, okay? PD is an object that you've created of pandas. I have not mentioned that here. First thing you need to do is import pandas as PD. Now you can rename this object as discussed earlier as well. Yesterday we had discussed NumPy, and NumPy was imported as NP. Okay, NP was the object that we named it as. Here we've named it as PD. You can name it as PS. We can name it as POS. We can name it as BS, whatever you want. Okay, but PD is the most commonly used object. So you do PD dot series with a capital S and data equals variable name. Now here your variable name is whatever your variable is, your list or your array, whatever that is. So if you have, say, list1 equals 1, 2, 3, 4, then your data will be list1. I hope this is understood. You do that. And that's it. If you would like to add a label, you must have another array declared of an equal length to the first data set. So here I had put, 1 second. Yeah. Here the length of list1 is 4 values, so it will be 3. No, just the length of this is, oh god, yeah, the length of this list is 4. Now, in order to add labels and index over here, I create another list. List2 equals A, B, C, D. Okay. And over here, all I have to do is rename this as list2. This, of course, becomes list1. As soon as you do this, your entire series will become labeled. You will see that in the code right now. After we finish series, I'll go through the code all together, right? Panda series can hold a variety of object types like integers, strings, and even functions. I have mentioned this. Like you can look at this code snippet over here. pd.series sum print length. These are all built-in functions, and you can see that a series has been created: 0 assigned to sum, 1 assigned to print, 2 assigned to length. Data type over here is given as object. Since functions cannot be defined like as proper functions, Python knows to call it a function, but since it cannot give it its own data type, every object that you create is an object. Whether it's a function, it's a method, it's a class, it doesn't matter. It will become an object when you're assigning it in a pd.series, that is. Okay. You can use an index to quickly look up its relative data using series. Alternatively, you can also use multiple such series and perform operations on them based on these indices. In this is, can't believe I got the spelling wrong. Yeah. Now let us look through the code. This is what we'll be doing. So series, this is the first main data type we will learn about. 1 second. There we go. About pandas is a series data type, blah, blah, blah. Here you've seen NumPy will just be taken along with pandas in order to add some data values. Okay, like here you can see you're creating a NumPy array just to show that you can add pandas to it. Now creating a series. You can convert a list, numpy, array, or dictionary to a series. Now here you have labels. These are just a set of labels that you've created. Okay. You have one list over here. You have another array. You have an array over here, and you have a dictionary over here. Okay. Note that all three of these objects have the same length. ABC 10, 20, 30, 10, 20, 30, A10, B20, C30. All three of these things have the same length. Now, if you want to use lists, you can see all I do is pd.series data equals my list, and it creates one. But what if I don't want to put the data equals? I'll just, 1 second, let me run the rest of it. Boom, 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 boom. And pd.series my underscore list. Still gives you that. As long as the parameters come in the right order. After the first parameter, if I give the second parameter instead of the first parameter, it won't work, obviously. But as long as I get my parameters in the right order, I will get my output. Now, instead of my list, if I want to do labels, let me try. Oops. You see, a series has been created for my given labels, A, B, C. Say I add another variable T. I do it again. 1 second, pd.series of labels is giving me, oh, I haven't run this. There we go. You see pd.series of labels gives me another variable T. Okay, let us reset this to align it with the rest of the code. Boom, 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 boom. Any doubts so far? Is it understood?
No. Yeah, it's understood.
Okay, thank you. Now again, I want to apply labels to my data from my list. So obviously I do data equals my list and I do index equals labels. And you see the 0, 1, 2, which are the basic index values, have been changed to A, B, and C. Now I can name this as whatever I want to, but for ease of understanding, I've named this as ABC, obviously. Again, you can see here, as long as the parameters are in the right order, the answer will be the same. This is the same as this. Okay, very simple to understand. Let us go forward. pd.series of ARR. What is ARR? It is an array that I've created using np.array, numpy.array, 10, 20, and 30. That is what this array contains. Okay, so we have a series created, the name of ARR, as you can see here, which is an array containing 10, 20, and 30. Now, along with this, I want to add labels again. So I use the same format. Again, instead of this, I can just data equals ARR and index equals labels. And I'll get the same response, right? Wait, oh, perfect. Again, instead of the array and the list, now I want to add a dictionary. You see, by default, when I put the dictionary over here, the index values are not 0, 1, 2. The index values are the key values itself. Okay. So whatever key values I put here, if I put index equals labels, what will happen here? Comma labels. You see, these have not changed, obviously, which means, but there is some change in this, I would assume, correct? So I will do something. I will rename the labels to be D, E, and F. I will run this, and then I will run, oops, this. pd.series D, comma labels. See, the values of these have become NaN. Can anyone tell me why?
Not a number. No, it's a
Sorry?
number. It's not a number
It's not a number, sure, but why do the values of D, E, and F have NaN assigned to them?
because it's a dictionary and we can't label them, I guess.
Correct. In dictionary, every key has an assigned value. Okay, you are absolutely correct. A has been assigned the value of 10, B has been assigned the value of 20, C has been assigned the value of 30. Now I have put the labels D, E, F successfully into this dictionary, but I have not given them any value. So they will be khali. That is why we have NaN over here. If I revert this again and run this for the sake of understanding, that is, and again, you see this back. Boom, there we go. Okay, now what about the data in a series? One second. Okay. This. Okay, good. What about data in a series? If I want to add some data types in a series, pd.series data equals labels. This is fine. I have basically what I've done is this labels list. I've put them in the series. That's fine. pd.series of some print len. You see that these are built-in functions. What if I put something like pow? You have another one. Something like split. Split is not defined. Okay. Let's say, what is another built-in function? Whatever. You can basically, sorry, max. Okay. If there's max, then there will be min. If there is min, there might be argmax. Nope, argmax won't come because that is a part of NP specifically. But yes, you see that as we get functions, we can keep adding them onto our series. All you have to do is you have to simply put them in this nice little list over here. Okay. Sorry, does someone want to speak? Yeah, Vignesh, do you have a doubt? Vignesh? It must be a mistake. I'm going to disable you for now, but text me if you actually have it out. Okay. Yeah. Using an index. The key to using a series is understanding its index, these values that you see to the left over here. Pandas makes use of these index names or numbers by allowing for fast lookups of information. Works like a hash table or a dictionary. Don't worry about hash table. Most of you might not understand that right now. But look at the dictionary. What you know of a dictionary is that it has a key and every key is assigned a value. Hash tables are similar to that. But in a series, whatever value you have given, the index which is next to it, that is the most important. That is your identity. As you're in college, every one of you has a registration number, and you will see that no two registration numbers are ever the same. It might be the same number, but then your ID will be different, like BCE, BEC, MIC, MIS, whatever. Okay. So in here, in a Panda series, every object that you add into the series also has its own registration number. That we can call them as indexes. Now let us see some examples of how to grab information from a series. Let's have two series, series 1 and series 2. So SER1 is panda.series of 1, 2, 3, 4. This is your data. Okay. You can just do data equals, and you'll get the same response, obviously. Data equals 1, 2, 3, 4, and index is USA, Germany, USSR, Japan. Perfect. I will run this and I will get this series. Series 2 is 1, 2, 5, 4. This 3 has become a 5. And I will do data equals just so it's easy to understand, that is. USA, Germany, Italy, Japan. See, the USSR has become Italy, and the value of it has also changed from 3 to 5. Now let's say series 1 of USA. I want to search the key value USA. What value does it have? Now, if I want to search series 2 of Italy, can anyone tell me what value this will have?
5.
You are correct. This will have the value 5. Very simple to understand. Now, you can perform operations off of these indexes. You do series 1 plus series 2. Now, all of us know that every value in series 1 and series 2 are the same except Italy and USSR, which are unique in series 1 and series 2. So once you add them, what will you get? Germany becomes 4. 2 plus 2 is 4. Italy becomes NaN. Since you're adding the value of 5 and Italy does not exist over here, the entire key value gets erased and the value of this gets reset. Okay? So if a value exists in SCR2, but it does not exist in SCR1, then its original weight that it holds, its value, all the hard work that it has done, it will be gone. This 5 has become an NaN. Similarly, you can see in series 1, you have USSR with the value 3, but in series 2, you don't have any such thing, right? So since you see that, since the keys do not exist, the values have been erased. Everything else gets added to itself. Germany is 2 plus 2, 4. Japan is 4 plus 4, 8. USA is 1 plus 1, 2, right? Series 1 minus series 2 is you're subtracting everything. And again, since you don't find the value of it in both of the key values in both of the series, you see NaN as a response, right? So far, so good. Let us move on to data frames. As we mentioned before, we're done with series, and now we're done with data frames. Well, we will be done with data frames now. All right, let us go here. See what a data frame is. Data frames are the workhorse of Pandas and are directly inspired by the R programming language. We can think of a data frame as a bunch of series objects put together to share the same index. Let's use Pandas to explore this. Okay, fine. Now, is there anyone here who knows the R language? Because I personally don't. Okay, it is a pretty rare language to know. So if you know it, I will be very impressed. Second. Data type float 64. Basically, whatever the number of decimals you have, it's been doubled. It's usually float 32. It's now float 64. That's all that is. Right? Um, right. Okay. So I'm going to assume no one here knows R programming language. I don't know it either. But all I know is it is somewhat used as a database management of programming language. I think so. All right. Now we can think of a data frame as a bunch of series objects put together to share the same index. Let's know what that means. Import pandas as PD, obviously from numpy.random import rand_n. Now you remember from yesterday, this rand_n gives you a random set of values over a fixated normal, which includes both negative numbers and positive numbers. Usually you'll see them from the range of -5 to +5. Maybe if you're very lucky, it will generate something over that range, but it is a standardized distribution normal over this. Now, what the seed does is it gives you a fixed set of values every time. So np.random.seed101 will only give you, okay, has given you some different values, but what it does is it creates a random generation. Has anyone here played Minecraft? Yeah, so we have a few
Yeah,
people that have played. Yeah.
yeah,
So in Minecraft, when you create a new world, you have to type in a seed sometimes when, like, if you want to, or just have it randomly generate a new seed for you in Minecraft. So what it does is it tells the program that, okay, the program has to follow this seed, which means this set of instructions, this particular set of instructions in which it will create its world generation. So maybe if one number is off, a forest which is supposed to spawn in this location will not spawn in this location. Every seed is different. All this the np.random.seed does is differentiates between the first result to the second result. If I run this again, you see that it is the same. And I run this again, see it's the same. But if I do 102 now, see it changes. And I run it again, and you see it change. So every seed is its own seed, right? Let us revert back to 101, and you see it is the same seed again, right? Now, df is a data frame object that I've created, is equal to pd.dataframe. Note the format, the D and the F are capital. In series, you had the S in series was capital. In data frames, the D and the F will be capital. Rand n of 5, 4. That means a randomly generated common distribution, which is a matrix of 5, 4. This is your data. Index equals A, B, C, D, E dot split. Because you don't know, instead you can just put A, B, C, D, E. Instead, you just put A, B, C, D, E dot split. It's a simpler way of writing the code. Okay. Columns equals W, X, Y, Z dot split. Instead, you can just do W, X, Y, Z, but that's tedious, right? Who wants to go through so much hard work? So I run this and I get this as my data frame, right? Now, selection and indexing. Let's learn the various methods to grab data from a data frame. df of W. Let me run this again since I changed the seed, right? df of W. Notice the 2 square brackets over here. Okay. W is this column right here. You see that it has been printed over here. W, Z. These two brackets have been, columns have been printed over here. There you go. If I want W, X, I don't like how Z is looking at me. I'll do X. Boom. You have X. There you go. If I want X, W, let me, 1 second. X, W. You can flip it up as well. What if I do W, W? It doesn't care. Or if I do W dot W and W, gives me 3 of them. It does not care. SQL syntax, this is not recommended because usually this is not the form of syntax you follow in Python. It'll just confuse you. So just don't worry about this. Let me just delete that, right? Data frame columns are just series. These columns that I've created, W, A, B, C, D, these are basically just series. If you look at the type, also this type function over here gives you the data type of whatever it is, right? If I say A equals 12, type of A, boom, int. B equals hello, type of, oops, B, str, that's string. Okay, quick explanation that is. There you go. Pandas.core.series.series. This is the original path for this series function from Pandas. Excuse me. Creating a new column. df of new equals df of W plus df of Z. So all the values of W and Z will be added to this new column. 1 second, let me just rerun this. 5, 4, 3, 2, 1. What is this? 5, 4, 3, 2, 1 D type are in columns. Index. Oh, second. This is new 2. All right. I was trying to make a new column. Sorry. This is still running. This is still correct. df of new equals df of w plus df of z. Sorry, I made that accidentally, right? Now, if I want df of x to be added instead, I can do that. And your new will have all the values of df of w added with all the values of x. You can cross check it. 0.30 plus 0. Plus 1.69, nice, is equal to 1.199. Minus 0.13 plus 0.39 equals 0.255, whatever, right? It checks out. The computer knows math better than I do. Removing columns. If you want to remove a column, if you don't like how it looks at you, you can simply do df.drop. You can drop the new axis that you've created. If I want to drop another, second, boom. If I want to drop W, you see an error because I have not mentioned which axis I have to drop it from. See, this happens. I have dropped it, right? Let me just run all of this code again. 1, 2, and notice every time I do rand n, it generates a random number of units again. 1, 2, 3, 4, 5, 6, 7. And you've dropped the new axis again. Not in place unless specified. So if you don't specify this and assign it to another variable, in that case, it will be the same thing. It will just display it to you as like what it would look like if new was dropped. Okay. In order to confirm this displacement, what you can do is you can just do in place equals true. How can you remember this? You've done something wrong. It has not taken in place already. So this is the same way. This thing needs to be in its right place. Therefore, in place equals true. If I just do place equals false, and I do boom, boom, it shows this, but then df again will have the new thing. See this? But no, let's get rid of this for real. See true, and you can see df not having the new thing again. Let us create another one, and you see it really does not have the new column again. Okay. In that way, you can drop rows as well. Also, you see what this axis does? The 0th axis will be this one, the axis with the rows in it. The first axis, the axis which has the value 1, will be columns. Has any one of you like written your cats or fats and been confused as to which is row and which is column, and therefore you accidentally sat in the wrong seat? Because it happened to me once. I was writing my I don't know, COA exam, yes. And I sat in this dude's bench and he was all confused and he was just staring at me for 5 seconds. I said, bro, move. I got scared. Why should I move? This is my seat. Then he went to ma'am and then I got scared because ma'am was very scary looking. And then she came to me and then she looked at me like she was about to slap me. And yeah, basically I was sitting in the last bench. I was supposed to sit in the first bench. And yeah, I couldn't cheat. It's very bad for me. Anyhow, axis equals 0 refers to rows and axis equals 1 refers to columns. I hope you understand this. Understand from my example of not being able to cheat. df.loc. Now this dot loc is basically kind of like locate. You're trying to select rows. Now A will give you this, but if I do, wait, let me rename this. If I do D, will give me the last row. I know how to view columns. I can just simply do df of w. If I want to view rows, I have to do df.loc of the row name. Perfect. If I do C, I get to see the C row. Okay. Name C D type float 64. D type is basically its data type and name is the name of the row. Or select based off of position instead of label. df.iloc2. To be honest, I know what loc stands for. It stands for locate, but I never knew what I in this stands for. So excuse me for not answering that question. But what it does is it gives you the specific location, right? That's all it does. If you want 0, that'll give you A. If you want 1, it gives you B. Oh, maybe it stands for index locate because it's calculating it based off of the index. So index 0 is A, index 1 is B, index 3 would be D, and index 4 would be, oh, there is an E, yes. Index 5 would be out of bounds. Okay, can anyone tell me why here it shows the A, B, C, D and not the E, but here I can access E? Can anyone tell me why? Oops. No, okay, I can't show that. It's just 4. Yeah, can anyone tell me why I cannot see it over here, but I can see it over here using the index? The answer is right in front of you guys, by the way.
Bro, because you dropped it.
No, I dropped it, sure, but I can still access it. I should not be able to access it if I dropped it. I can't access new now, no? You see this in place equal to true? Since I have not put this in place equal to true over here, it has not taken in place properly. Theoretically, if I do df now, it will show the E values as well. Okay. Now if I do in place equals true, that will theoretically remove E, but I don't want to do it now because once I'm done with this PPT, I will do it, right? Let me do this because I want to complete the other things first, right? So I'm done with D at df.loc, iloc, B comma Y. That is basically giving you which row and which column. In column B, sorry, in row B, column Y, I'm still confused about rows and columns. In row B, column Y, the value is wait. The value is 0.0315, whatever. And you can see in row B, column Y, 0.031579, minus, obviously. If I say row C, column A, anyone tell me what the answer would be? Sorry,
2.15.
are you sure it is 2.15? Because look at the input. I've put row C, column A. Is there a column A over here? If I put W, sure, that would be 2.15. But if I put A, that's an error because there is no column. Okay, just a little trick question. Now df.loc of A comma B and W comma Y. That generates matrix with A W A Y B W B Y. Second, let me just boom. You see this small little matrix over here that has been generated. Okay, that is all about locate and index locate. Conditional selection. An important feature of pandas is conditional selection using bracket notation, very similar to NumPy. In NumPy, you remember that we can choose whether we want to select some objects or not. Let me run this. In pandas, data frames in pandas, again, you can choose whether you want some things or not. You can choose whether you like this person or you hate this person. So if I do df greater than 0, you see all the negative values become false and all the positive values, anything that is bigger than 0 becomes true. df of df greater than 0. This is basically telling me what are the values. Fine, you're telling me this is false, this is true, that's fine. But what are those values? I want to see them. That is when you can see these values. Okay. If I do data frame less than 0, and then I do data frame of data frame less than 0, you see all of the values which are less than 0. And here you see the truth table as well, right? That's all. Now, df of w greater than 0. Everything linked with w, which is greater than 0, will be skipped. If I just do this, you see in w, oops, sorry, in w, whatever is greater than 0 is displayed. But if I do df, sorry, df of this, boom, you can see all the values pop up. Now df of df w greater than 0 with respect to y. A, B, D, E. Sorry, A, B, D, E. Why is C skipped over here? Because with respect to W, C is in negative. You just have to compare 2 or more columns and you need to see this. That is all this does. And Y comma X just adds another column. So if I do Y comma X comma Z, that'll just add another column. I remove this because I don't like it, removes that column. There we go. For conditions, you can use straight line and add reserve with parenthesis. And this is or and this is and. You remember the logical operators that we had done earlier? This is all that is, right? This is or, this is and. There we go. df of w greater than 0 and df of y greater than 1. You do not have any such values, therefore this is empty. That has not happened to me before. Usually I have at least one value. But there is no such value such that df of w is greater than 0 and df of y is greater than 1. So I guess you guys are lucky. More index details. Let's discuss some more features of indexing, including resetting the index or setting it something else. We'll talk about index hierarchy as well. So we have our nice little data frame over here. Okay. Reset to default 0, 1, n index. Here you see initially your indices are set to A, B, C, D, E. But now you don't want them as A, B, C, D, E anymore. You want to remove these A, B, C, D, and you want to assign them to another column called index. Just that's the name by default, by the way. And you want to go back to 0, 1, 2, 3, 4. You use this function, reset underscore index. Remember this format, or if you don't want to remember it, you can always get a cheat sheet from the Pandas official website. All right. I'll share links and these PPTs will also be shared with you. PDFs, sorry. You can go through them whenever you'd like. New wind is equal to CANYWYORCO. Pretty sure these are US states, California, New York, Wyoming, Oregon, Copenhagen. I have no idea. I was about to guess that was copper. DF of states equals new wind. All right. Now you've created a new column called states and you've assigned all of these names. So let me just, oops, 1, 2, 3. There we go. You have a new column called states with all of these states over here. Okay. Now df.set index states. Here you had reset index. Now you're going to set the index. You don't like how this looks? All you do is you remove the ABCDE that was previously placed up here. the A, B, C, D, E from here, you just remove them and you replace them with C, A, N, Y, W, Y, O, R, C, O. This becomes your new data frame. And you can see the original data frame is still not changed. Therefore, you need to do in place equals true. Once I do that, boom, this will be my official data frame. Sorry. Remember, Python is case sensitive. So if you accidentally do TF or whatever, it is going to mess your code up. There you go. Okay, I hope this is understood. Multi-index and index hierarchy. Let's go over how to work with multi-index. First, we'll create a quick example of what a multi-indexed data frame would look like. You have outside equals G1, 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 G2, G2, G2. So all you have is G1 and G2. Inside equals 1, 2, 3, 1, 2, 3. Higher underscore index is a variable that you've created equals list of zip of outside comma inside. So all you've done is use the zip function to create a list using the outside and the inside variables. These are all predefined functions. Higher underscore index equals pd dot multi-index dot from tuples of higher index. This is a predefined function from Pandas. So let me go over this. Multi-index is basically you creating a multiple indexed data frame using the given data values here. Okay. So you see levels are G1, G2, and 1, 2, 3. But the labels are 0, 0, 0, 1, 1, 1, 0, 1, 2, 0, 1, 2. Okay. These are your indices. Now let us fill these data values up. Let us use pandas.dataframe using numpy.random.randn 6, 2. That's 6 rows and 2 columns. Index equals, let's simplify this by doing data equals from that. Data equals numpy.random.randn of 6, 2. Index equals higher underscore index. Columns equals A, B. So you have 2 columns over here. Obviously, you can rename your columns however you know. Hello, bye. Boom. You have 2 columns, hello and bye, and you have multi-indexes. So your first index here is named under G1, which is group 1, and your second index here named under G2. So you see you've put G1, 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 and G2, G2, G2. What pandas.multi-index does is it sees wherever there is a common value and it puts it together under 1. So now G1 will group all of these together. G2 will group all of these together. This is what I mean by Python can handle its memory very efficiently. Take that, Java. Now let's show how to index this. For index hierarchy, we'll use df.loc, which is basically df.locate. We've seen this earlier. If this was on the columns axis, you would just use one normal bracket notation df of. Remember how we called w over here? All we did was df of w. For the row, we did df of df.loc of a. Similarly, while using multi-indexes, you have to use df.loc for rows and df of for columns. I hope this is understood. Calling one level of the index returns the sub data frame. See G1, I got G1 specifically. If I do G2, boom, I get this. G1, I get this. What if I do gf.loc of 1? Why does it say indexing error over here? Because the outermost index is G1. I always have to follow the outermost index only when I'm using the loc function, that is. df.loc of G1 dot loc of 1. This gives me this. Now, similarly, if I do, one second, let me run this and let me do G2. See, the values have changed to 1.04 and 1.29. See them show up over here. There we go. So you need to put the first index and then put the second index. Okay. Instead, if you want to print hello and bye, we can do is df of, oops, forgetting my keyboard is in capitals. See df of hello, oops, oh god damn it. There you go. And if bye. See these showing up? This is extremely easy. Okay. Now we got df.index.names. This basically shows you the names of these indices. And we see that there are no names given. Frozen list is a predefined data type, which means you cannot change it once it's made. None, comma, none. So we give them names. df.index.names group, comma, none. See, the first index has been given the name group. Second index has been given the name none. We do that, and there we go. Your hello and bye have been predefined, obviously, but group and num. These are your two new data. df.xs of G1 basically removes all the group identification and just gives you G1 in general. Oh, there you go. G1, comma 1 only gives you the first row. Why does this not work? List keys are not supported in Access passes tuple instead. This comma G1, this comma G1, comma 1. This works. This does not work. Type error. List keys are not supported in Access. Nope, that will not work. Okay, I will go through this later. I'm sorry. And tf.access 1, comma level equals num. I'm going to assume this works. Yes, there we go. For some reason that was not working. I will go through that later. Only the groups are shown and the first row of each are shown. See, this one and this one. Okay. These are data frames for you. We still have missing data, group by, merging, joining, and some basic operations to do. I'm going to go through missing data and group by now. Merging, joining, and concatenating is a very simple process. You just have to use something called pd.concat. And there are some examples given here of each. So you can go through them yourself. I will share that material with you people, obviously. And some basic operations are also given. These are basically examples of functions that give you unique values or the headers, or you can apply your own predefined functions over here. I'll be sharing these with you. I want you guys to go through this, and tomorrow we will be discussing these in class since there is somewhat of a time crunch. All right. Let's go through missing data now. Are there any doubts in data frames or series? Anyone? Guys, you all can feel free to speak up, please.
No doubts.
No doubts. Thank you. Okay. All right. Missing data. Sometimes you see that your data has proven to be NaN. I've seen them in a few examples. Yes, you see over here. Series 1 plus series 2, it gives you NaN. Now, what if your data is missing in a data frame? How do you tackle that? You import numpy as np, pandas as pd, you create an example data frame with some predefined NaN values. Notice the first row is filled and the last column is also filled. Okay, this is just for perspective, obviously. You do df.drop na. What this does is, by default, the axis is set to 0. Therefore, following the rows, it drops anything that has an na value, right? So here, axis equals 0. will give you the same answer, right? But if I do axis equals 1, you see that everything has been following the columns instead. It does not follow rows, it follows columns. So C is the only column that has all of its values intact. Therefore, that is the one that has been printed. And axis equals 0, here 0 has been printed, because that's what it is. Now, what is thresh equals 2? Your threshold of searching is equals 2, which means the index that you search in is 2. Therefore, 0, 1, 2. Your second index, you have two any values. Array. Therefore, I remove the second index because it has any values. We will drop the entire row. Let's say I want to replace these values. df.fill na value equals fill value. Let me just run this and run that. Yeah. df.fill na value equals fill value. Now, obviously, you can put whatever value you would like to put over here. Let's put hey. Therefore, all of these values that are nan become 68. Let's say, oh, there we go. All of these values become 420. Let's just paste this value for now. There we go. df2. Here I've created a new data frame called df2, and I've changed it with df of a, this column, dot fill na, value equals df of a dot mean. What is the mean? You see the mean function over here. Now tell me, what is the mean of set of numbers? Anyone?
Average.
Average. Okay, good. That is correct. The average of whatever numbers that you have, that is the mean. The same name, different. No, wait. Same meaning, different name. Yeah. So 1 plus 2 divided by 2 is 3 divided by 2, which is 1.5, which is the mean of all of the values in A. Let's say I want the mean of B. Since there are no other numbers in B, the mean of 5 will be 5. So if I do, let's run this first. And boom. If I do B, you see all of the values have become 5. Since there is no competition, the mean value is the highest value possible. And if I do C, since there is no empty value over here, you can see that there is no average to fill. Let me replace this with A for now. There you go. And you see that your original DF is still intact. I've done this, but if I do in place equals true, I can't do that. Please explicitly type to a compatible data type first. Oh, okay. Say 6. Then I do df. It's become fill value for some reason. Fill na value equals 6. Ah, I see. So the first time I executed it, it had decided to change it to fill value. Therefore, all the values of nan have become fill value now. Now I cannot change it anymore. I need to fill value and remove this. This, and you see that as well. It has already taken in place, but that was simply a warning. There we go. Okay, this is missing data. I think we have some more time, so we can go through group by. I'll go through it quickly. All right. Any doubts in missing data? Okay. So we have group by. Let me remove this. Yeah. The group by method allows you to group rows of data together and call aggregate functions. So you have multiple rows of data. You call all of them and you slap all of them. You have one function and you apply them to all these rows together. That is what the group by method does. The group by is your teacher, your class did a mass bunk. The group by, your teacher is going to slap all of you together. That is what this does. Import pandas as PD. Now you create a nice little data frame. Company, Google, Google, MSFT, MSFT, FP, FP. So Google, Google, Microsoft, Microsoft, Facebook, Facebook. Person, Sam, Charlie, Amy, Vanessa, Carl, Sarah. Couldn't find better names to give them. Wow. Sales equals 200, 120, 340, 124, 253, and 350. Now I create a data frame for this data, and I see this perfectly lined up in a nice little table for me. Now you can use the group by method to group rows together based off of a column name. Say your column name is person, you can group them by their names. A second. I do person. There you go. You can save it as another variable. So let's do by pers per equals gf dot group by of person. Got it. There you go. So you see by comp dot mean. Let's run both of these codes. Let's do by comp. By comp. Oh, I forgot to run this. There you go. It shows a data frame group by object. But obviously you can't print it. What if I try to print it? It will only print the object type. You can only access this by using functions, right? So I've created another data frame over here by person and by company. By company dot mean will give me the mean sales for each of these companies. Why is this not running? Repeat data type equals true. Mean nanops convert string. Aggregate function field. How main data type object. And that is called creation of a graphic. Sorry, someone's mic was on. Let me refresh this. Reload. I think it's best I don't touch the code for now. I'm gonna try and run it for now. Must be something I have not downloaded. My bad for that. But yes, you can see that this group by, you can allow, like you can put this value to a variable. Okay, so I've put it to by comp over here. Then I've called aggregate methods off of the object. So I've called a mean function to all of the values available in this by comp. So what this is it's grouped by company. So Google have the aggregate values of 200 plus 120, that's 320 by 2, do the math. It's 160. In Microsoft, I have 232, do the math, and checks out, right? Everything here is giving you the mean. Over here, I've grouped by the company and I've returned the mean. Again, it's the same thing. Instead of assigning it to a variable, simply call the entire thing again. tf.group by company.mean. More examples of aggregate methods. By company of SGT. This gives you the standard output. So over here, you have the standard deviation over here of all of the values. Minimum. Min is minimum, max is maximum. You see which person has done the least amount of sales. And here you see which people have done the max amount of sales in each company. Count. How many people and how many sales they've done. Describe. Describe is the god of group by because it gives you everything possible. Okay, gives you the count, 2 people in sales, mean 296.5, standard deviation 75.66, minimum 243, 25% would be this, 50% would be this, 75% would be this, and maximum is 350. Count, mean, standard, min, 25%, everything for Facebook, excuse me, Google, and Microsoft. And this is by com.describe.transpose, which basically represents all of this instead of vertically, represents it horizontally. So these values are for Facebook. These values will be for Google. These values will be for Microsoft. You see the dot 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 over here because this value is way too long to print. So sometimes it tends to skip this. In Python, when you're dealing with larger data sets, you'll sometimes have CSV files which have tens and thousands of values. When you're trying to handle large amounts of data, that tends to happen. You'll have tens and thousands of people in one Excel sheet, one CSV file. And in order to shorten that and not print everything, what Pandas does is by default, it removes the majority of it. Just shows you the first one, the second one, and the last one. So there's the dot dot dot. By com.describe.transpose of Google. This only gives you all the values for Google, nothing else. Okay. Again, once again, I apologize for not being able to run the code. I seem to be missing some repositories. I will go through this and I will, rerun these codes again tomorrow in class. Other than that, the time is 10:15. I have merging, joining, and concatenating, which is again a very easy topic. Okay. I will be sharing this code as soon as possible, like right now, right after this class to you people, and some operations. You can go through these like properly, and we shall be discussing these tomorrow. Also, make note, tomorrow we'll be discussing matplotlib, which is a very important module in Python because that allows you to obviously see graphical representations of everything that you're doing. How you're doing it, why you're doing it, you see the graphical version of it. Okay. Make sure to not miss tomorrow's class. And obviously, tomorrow will be the last time you ever hear my voice. So goodbye forever before that. And yeah, if there's any doubts, please bring them on. I will stop the recording.